Welcome to an extraordinary exploration of the life cycle of stars, one of the most profound phenomena in the cosmos. Stars are not merely twinkling lights in the night sky. They are dynamic entities that go through a series of dramatic and transformative stages. These processes not only illuminate the universe, but also forge the elements that are essential for life as we know it. Today, we delve into the remarkable journey of stars from their birth in cosmic nurseries to their ultimate demise, and how each stage influences the grand tapestry of the universe. Our cosmic journey begins in the heart of a nebula, an immense cloud of gas and dust spread across vast regions of space. These nebulae are the universe's stellar nurseries, where new stars are born. Within the nebula, regions of higher density begin to collapse under their own gravity. As the gas and dust come together, they form clumps that heat up, setting the stage for star formation. This process is a testament to the delicate balance of forces at play in the universe. As the material continues to collapse, a dense core forms at the center of these clumps. This core is the precursor to a protostar, an early stage in stellar development. The protostar is surrounded by a rotating disk of gas and dust, and its core temperature rises as gravitational energy is converted into heat. This process is marked by dramatic increases in temperature and pressure, leading to a crucial milestone in the star's life cycle. When the core temperature reaches about 10 million degrees Celsius, nuclear fusion ignites. Hydrogen atoms in the core begin to fuse into helium, releasing enormous amounts of energy in the form of light and heat. This marks the birth of a main sequence star. The main sequence phase is where a star spends the majority of its life, achieving a stable balance between the outward pressure from fusion reactions and the inward pull of gravity. During this time, the star's energy output remains relatively constant, allowing it to shine steadily. The main sequence phase can last for billions of years, depending on the star's mass. Stars are classified based on their mass, temperature, and luminosity. On the Hertzsprung-Russell diagram, which maps these characteristics, we see a variety of stars, from cool, red dwarfs to hot, blue giants. Low-mass stars, like our Sun, have lifespans of about 10 billion years, while massive stars, which burn their fuel much faster, may only last a few million years. Each type of star plays a unique role in the cosmic ecosystem. As a star exhausts the hydrogen fuel in its core, it undergoes significant changes. The core contracts under the force of gravity, while the outer layers expand and cool. This transformation turns the star into a red giant. Red giants are characterized by their enormous size and relatively cool temperatures, giving them a reddish appearance. The star's outer envelope becomes increasingly unstable, leading to dramatic changes in brightness and size. In the case of stars like our Sun, The red giant phase is followed by a period of intense activity. The star sheds its outer layers, creating a colorful and intricate shell of ionized gas known as a planetary nebula. This process releases a vast amount of material into space, enriching the interstellar medium with elements that will later be incorporated into new stars and planets. The core that remains after this ejection is a white dwarf, an incredibly dense, hot remnant composed primarily of carbon and oxygen. White dwarfs are fascinating objects. They no longer undergo fusion reactions and slowly cool over billions of years. As they fade, they become faint remnants of once mighty stars. The cooling process of a white dwarf is a slow and gradual one, ultimately leading to a state where it no longer emits significant heat or light. For high-mass stars, the end of the main sequence is even more dramatic. After the red giant phase, these stars undergo a supernova explosion, a colossal release of energy that can outshine an entire galaxy for a short period. The core collapses under gravity to form a neutron star, or, if the original star is sufficiently massive, a black hole. The supernova explosion disperses heavy elements such as iron, nickel, and even elements like gold and platinum into the surrounding space, contributing to the formation of new stars, planets, and potentially life. Neutron stars are incredibly dense objects with a mass greater than the Sun compressed into a sphere just about 20 kilometers in diameter. The extreme density leads to fascinating phenomena such as pulsars, neutron stars that emit beams of radiation from their magnetic poles. As these beams sweep across our line of sight, they appear as regular pulses of light. In the most massive stars, the core's collapse may lead to the formation of a black hole, a region of space where gravity is so intense that nothing, not even light, can escape. Black holes can have profound effects on their surroundings. They often possess an accretion disk, where matter spirals in, heats up, and emits X-rays. Black holes can also influence the formation of new stars and galaxies by exerting powerful gravitational forces. The life cycle of stars is a continuous process of creation and destruction. The material ejected by dying stars, whether in the form of planetary nebulae, supernova remnants, or accretion disks, enriches the interstellar medium with the building blocks of new stars and planetary systems. This recycling of stellar material ensures that the elements necessary for the formation of planets and life are constantly being forged and redistributed throughout the galaxy. As we observe the stars scattered across the night sky, we witness the grand processes that drive the evolution of the universe. Each star's journey, from its birth in a nebula to its death as a white dwarf, neutron star, or black hole, plays a vital role in the cosmic cycle. These stellar processes not only shape galaxies and solar systems, but also contribute to the very fabric of the universe. In exploring the life cycle of stars, we gain a deeper understanding of the forces that govern our universe. Each stage in a star's life reveals a part of the grand cosmic story and highlights the interconnectedness of celestial phenomena. Thank you for joining us on this enlightening journey through the life cycles of stars. As we continue to explore the cosmos, let us be inspired by the incredible processes that shape the universe and connect us to the stars above. Stay curious, keep exploring, and let the wonders of the universe ignite your imagination and sense of wonder.